Hello, and welcome to this fifth set of problems on arithmetic progression, geometric progression, and harmonic progression. We have solved 40 problems, so now we will solve next 10 problems. Without further ado, let's get started. But before I start, I would like to say one thing that I always say that when I'm reading the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. Problem number 41 says that find the sum of the product of the first n natural numbers taken two at a time. So the required sum S would be 1.2 plus 2.3 plus 3.4 up to n minus 1 into n. So this is nothing but sum of all numbers squared minus sum of square of numbers divided by 2. Because when you will expand this, for example, there is a plus b whole square, then you get a square plus b square plus 2ab. And if there is a plus b plus c whole square, then you get a square plus b square plus c square plus 2ab plus 2bc plus 2ca and so on. So when you subtract that from the square of terms, then you would have the product of terms 2 taken together multiplied by 2. So we divide by 2 for that. Now this is easy because you simply substitute the formula for this and then you get the result. The other way would be to find this nth term and then take the sum operator over that. Problem number 42 says that a postman delivered daily for 42 days, 4 more letters each day than on the previous day. The total delivery made for the first 24 days of the period was the same as that for the last 18 days. How many letters did he deliver during the whole period? So we let A letters to be delivered on the first day and D is equal to 4. So according to the question, the sum of letters for the first 24 days is this and for last 18 days is this. The reason the first term is different is because this would be the 25th day's letters. So the first term of the series would be different. Number of terms would be different. For the first it would be 24, for the second it would be 18 and common difference will remain same. So the number of letters on 25th day would be a plus 24 into 4. We multiply that with 2 in the formula. And similarly for left hand side, you solve, you get a is equal to 206. Now we substitute in the sum formula for 42 days, you get the answer as 12,096. Problem number 43 says that if Sn denotes the sum to n terms of an AP, Sn is equal to n square p, Sm is equal to m square p, m is not equal to n, prove that Sn is equal to p cube. So we substitute in the formula Sn is equal to n by 2, 2a plus n minus 1 into d is equal to n square p. Cancel out n, we take 2 to the right side, we get 2a plus n minus 1 into d is equal to 2np. Similarly, for Sm, we get 2a plus m minus 1 into d is equal to 2mp. We subtract, we get n minus m into d this side, and we get 2 into n minus m into p this side. So we cancel out n minus m, we get d is equal to 2p. Once we have d is equal to 2p, we can substitute either in this one or in this one, we get a is equal to p. So sum of p terms would be p by 2 into 2a plus p minus 1 into d. So this would be 2p. So minus 2p will come because of minus 1 will get cancelled with 2a. So p will remain inside and that will be multiplied by 2p. So it will be 2p square. 2 gets cancelled. P square into p is equal to p cube. Problem number 44 says that there are n arithmetic progression whose common difference are 1, 2, 3 up to n, respectively, the first term of each being unity. Prove that the sum of their nth terms is n by 2 into n square plus 1. So nth term of the first AP would be n, nth term of the second AP would be 2n minus 1 because common difference is now 2. For the third term, it would be 1 plus n minus 1 into 3, that is 3n minus 2. And for the nth term, it would be n square minus n plus 1. So sum of this AP would be number of terms by 2 multiplied with first term, that is n, plus last term. So that is equal to n by 2 into n square plus 1. Problem 45 says that if S1, S2, S3, S1, S2 up to Sm are the sum of n terms of m APs whose first terms are 1, 2, 2m and whose common differences are 1, 3, 5 up to 2m minus 1 respectively, show that S1 plus S2 up to Sm is equal to 1 by 2 mn into mn plus 1. So sum of first AP is n by 2 into 2 into 1 plus n minus 1 into d. For the second AP, it would be, first term would be 2 and common difference would be 3. For the mx AP, it would be 2 into m plus n minus 1 into m minus 1. So we take out the sum of this. This would be n by 2. 2 into first term would be 1 plus 2 plus up to m. And the common difference would be 1 plus 3 up to 2m minus 1. So we apply the formula, we get the result as half mn into mn plus 1. Problem 46 says that a straight line is drawn through the center of square ABCD intersecting side AB at point M so that AN is to NB is equal to 1 is to 2. On this line, take an arbitrary point M lying inside the square. Prove that the distance of M to the sides AB, AD, BC, CD of the square taken in that order form an AP. So we have our square ABCD. We have considered each side to be 3A. So we draw the line NR here, which goes through center of square such that N is to NB is equal to 1 is to 2. So since this is 1 is to 2, the other side, that is dr is to RC, would be 2 is to 1 because it passes through center. Now we draw this line, we draw PS, we draw QR. So if you see, then you will find that N is equal to NQ is equal to RC is equal to A, and QB will be also equal to A. The reason is that this is A parallel to that QB is there, that is A, and this is A, that's why NQ will also be A. Now if you see triangle NPM and NQR, they are similar. The reason is angle R and Q is common in both, and the ratio of the side would be 1 is to 3. So you see that 1 by 3 QR, that is this side, 1 by 3 QR would be equal to NP, that is this side. Okay, the reason is that if you see this clearly, I'll try to explain how it works out. So the bases are parallel here, okay, and this is an intersecting line. So this angle would be equal to this angle, and this angle will be equal to it will be common actually, and this angle is 90 degrees. So three angles are same, that's why the triangles are similar. Now MP is equal to X, NQ is equal to A, and QR is equal to 3A. So 1 by 3 QR is equal to NQ, and that's why NP is equal to 1 by 3 PM, which is 1 by 3X. Now if you look the distance of M from AB, that is P, it is X, okay, and we look at AD, sorry, distance of M from AD, then it is PA, okay, and that is equal to AN plus NP, but we have found NP to be 1 by 3x and AN is A, so it is A plus 1 by 3x. Now distance of M from BC is QB plus PQ. Now PQ is nothing but 1 by 3x again, and this distance is A, so that is A plus 3x, 1 by 3x. Now Bn minus Np is distance of, sorry, QR minus PM. QR minus PM is the distance of M from CD, that is equal to 3A minus X. So all the distances we have found are in AP. If the sides of a right angle triangle are in GP, find the cosine of the greater acute angle. So we let the sides of right angle triangle to be AR square, where AR square would be the hypotenuse if R is greater than 1. So A square R to the power 4 is equal to A square plus A square R square. So sorry, this should be R square. Hang on, let me see. So yeah, this should be R square is equal to 1 plus minus square root of 5 by 2. Now since R is greater than 1, so R square would be greater than 1, that is R square is equal to 1 plus square root of 5 by 2. Therefore, cosine of the greater acute angle would be A by AR square is equal to 1 by R square is equal to 2 by 1 plus square root of 5. Problem 48 says that if ABCD are non-zero numbers and A square plus B square plus C square multiplied with B square plus C square plus D square is equal to AB plus BC plus CD whole square, prove that ABCD are in GP. Now since this is given, we multiply the left hand side and we square the right hand side, then we take out the common terms and we get the equation as b square minus ac whole square plus c square minus bd whole square plus ad minus bc whole square. Now this would be possible only if b square is equal to ac, c square is equal to bd, and ad is equal to bc. Otherwise, the left hand side won't be equal to 0. So when we have this condition that b square is equal to ac, c square is equal to bd, and ad is equal to bc, abcd will be in gp. Problem 49 says that does there exist a geometric progression containing 27, 8, and 12 as three of its terms? If it exists, how many such progressions are possible? So we let A to be the first term, common ratio to be the R, and 27, 8, 12 to be Pth, Qth, and Kth term of a GP. So 27 is equal to AR to the power P minus 1, 8 is equal to AR to the power Q minus 1, 12 is equal to AR to the power K minus 1. Now here we would like to isolate this in terms of prime factors. So R to the power P minus Q is 3 cube by 2 cube, and R to the power K minus Q is equal to 3 by 2. Now this implies that now when you have this implies that 3k minus 3q is equal to p minus q. That is p plus 2q minus 3k is equal to 0. The way to arrive at this equation is you multiply this by p minus k. You take the power p minus k of this, and you take p minus k of this, and you'll find that these two have to be equal. Or otherwise what you can say is this is 3 by 2 whole cube, this is 3 by 2. So p minus q over here would be equal to third power of this. K minus q should be multiplied with 3 to achieve 3 cube by 2 cube. So from there this equation can come. So all you are trying to do is to equate the prime factor powers. So we have the equation p plus 2q minus 3k. Now one of the possible sets of solution is p is equal to 4n, q is equal to n, and k is equal to 2n. If this set of numbers is there, then the terms would be in GP. Now here n belongs to natural number, and there are infinite numbers in natural number set, so infinite set GPs are possible. Problem 50 says that show that 10, 11, 12 cannot be terms of a GP. So proceeding like the previous problem, we take them in the form of prime factors. So we arrive at the result 11 to the power k minus p is equal to 5 to the power k minus q, 2 to the power k plus q minus 2p, 3 to the power q minus p. Now these prime factors are different from each other, so each power has to be equal to 0 so that they can be equal. Now that implies that k is equal to p plus q, which is not possible since p, q, k are distinct. So with this we come to the end of problem number 50. In my next video I'll solve 10 more problems, so stay tuned for that. And if you found this video useful and informative, please subscribe to the channel and like the video, because that will motivate me to make more such videos. Also, if you want to say something, you have a comment, you have a suggestion, or you want videos on certain topics, leave me a comment below and I'll try to fulfill your demands. So with this we come to end. Enjoy.